All right, so in this video, I just wanted to go over the Atomic Red Team script that was used for the lab demonstration. Now, the purpose of this script is to run a series of different MITRE attack framework techniques that you would commonly see in various environments when it comes to essentially running cybersecurity related attacks. So, as you can see by the script here, again, this is entirely benign in nature because it's primarily used to really test the, I guess what you can call the security posture of your environment. So essentially what you see here is again a list of minor attack techniques and procedures. You have one that says T1566-001, atomic test number one, download macro enabled phishing attachment. And then underneath that, you've got one for creating a local account with admin privileges. Then you've got one for PowerShell fileless script execution. You got one for reg keys, suspicious bat file, scheduled tasks, service installation CMD, as well as process injection. And then one final one for delete a single file. So what I kind of wanted to do was go over well, just to give you a bit of background, so for those of you who have been following my like my original cybersecurity lab, this is actually a technically a separate environment altogether, and this one is actually installed on a VMware VM, and I believe this should be a Windows 10 instance, and this is actually a custom-made VM from Blue Cape, which is a they specialize in blue team security training. So this virtual machine was set up by them, and it's actually got a bunch of different custom tools on it that you can use for Windows forensics related tasks and whatnot. But anyways, I wanted to go over the artifacts that were left behind from this script. So I ran this script on this particular VM on the 15th. So as you can see, it's been quite a few days already since I ran the script. But one of the things that we can check is, as we can see here, we have one for create a local account with net admin privileges, for example. So one command that I always like to use just to take a look at the different accounts that are on a Windows device is netplwiz. Maybe you've heard the command, maybe you haven't, but essentially what this will do is this will show you the different user accounts that are local to this system. It'll show you the like standard users as well as the administrative users. So as you can see here, you've got this Atomic Red Team test user account that also happens to be a local administrator for the account. Now, this script created this, and one thing that we can use to verify the creation of this account is by looking at event logs as well. And so the type of laws that we want to look for is security laws with event IDs of like 4798, 4720, 4799, because those are usually tied to account creation and user account management. So what we'll do now is we will go to event logs. And then as you can see here under security, on the date that I specify, we actually have a security log confirming the creation of the art test account here. So this is one area you can look at, or really, yeah, between that and using the netplwiz, like, the netplwiz command, you can figure out, or at least quickly see what account may have been created that shouldn't be there, and then simply remove the account or any other suspicious accounts that may be there. And as you can see, we've got event ID 4722, which shows that the account was enabled. Account was changed, and then if you go to 479, we can see that local group membership was enumerated. And as we continue to look through the laws, you'll also see that this account was also added to certain sensitive security groups. As you can see, if you look down here, security ID, desktop, Elliot. So this represents the user that's logged into the device. Again, since this is a custom-made VM, technically I am logged into the local admin account that came with the custom VM. which would be Elliot's account, so to speak. As you can see, you got the member security ID, which would be art test, and then you've got the group that they were added to. And I believe this account was also added to some other groups as well. But of course, all that information you can find here in the event logs. And another sign that there's some malicious activity going on is that if you ever come in here and see that these logs, for whatever reason, aren't here, like they were cleared out, for example, that could be an example of an attacker trying to essentially hide their activity, or at least make it less obvious that they were in your system and tampering with stuff that they shouldn't have had access to in the first place. But in terms of user accounts, I would say that is a good place for any SOC analyst or cybersecurity analyst to start when it comes to checking just general like not infrastructure, identity access management basics. So just making sure that you don't have any accounts that are enabled when they don't need to be enabled, and just making sure that you know all of your accounts have or follow the principles of least privilege. So that's how I would typically address anything pertaining to accounts and user permissions in the cybersecurity perspective. So next we will look at, how about we look at registry keys. So in the script, you'll see that there was a MITRE ATT&CK technique used for basically editing a what's called a run key. Now, this is digging deeper into Windows registry hives. Now, there are 5 root keys to take into account when it comes to registry keys or registry hives. I mean, and they're going to be H key, current user, H key users, H key local machine, I believe H key classes root, and H key current configuration. So one way that you can view all of the registry hives is just to go to the registry editor. Um, Now in the registry editor, you will see that you have the classes root, you have the current user, you have the local machine, H key users, H key current configuration, etc. Now, when it comes to run keys, there's really 2 types of run keys. There's run keys and then there's run once keys. So if an entry is put into the run key, that means that the entry or executable or whatever was entered into the entry into that key will run every time the system is booted up, regardless of if it's under H key current user or H key local machine. Now the run once will just mean that the key and specifically the process tied to that key will only run once. And so if a attacker were to input some sort of process into the run key in the registry hive, either for current user or local machine, then what will happen is that process will run each time the machine boots up. Or in this case, actually, if it's under current user, then whenever that user logs in, I believe actually is when the process will run. But in order to find the run key that was initiated by this script, um, typically they will be under software. And in this case, I believe they will be under Microsoft. And let's take a look here. So Windows current version, and I believe it should be, yeah, there it is. Okay, so you got the run keys here. Now, as you can see, you've got a couple of entries. You've got zoom it, and then you've got, again, atomicredteam.exe. So essentially what that script did was once it ran, it inputted this atomicredteam.exe data value into under this registry hive, and essentially whenever this device is rebooted and powers back on, this executable will run. Under the run once, there's nothing here. So there's nothing here that specifies that a particular process or program is only meant to run once. So again, this is a common sort of method that can be used by attackers to really gain persistence into your system. Now, what that atomic red team.exe file does exactly, I am not entirely sure, but that is separate from the art attack script that was used in this test environment. But one thing that I would probably do is probably find that exe and then maybe run it in like a sandbox environment. That way you can analyze its behavior, look to see what artifacts it leaves behind, and hopefully if you have good like detection engineering with your sims and whatnot, you'll be able to like maybe get an alert and be able to view any entities that were impacted by that executable that way. But that is just something to consider when dealing with registry keys. So next, what we will look at is, next I think I should discuss process injection. This is a bit of a trickier, a little bit more of an advanced attack. So essentially the point behind process injection is that it runs malicious code using a commonly used or familiar process on a Windows device. I believe what it does is it runs the malicious code into the memory address space of a legitimate process. So, for example, if you commonly use something like I don't know, Notepad Plus, or uh, maybe some sort of like PDF application or something like that, then what can essentially happen is when that process or when that application is ran, malicious code can be injected into your device and it can do all sorts of nasty stuff. Again, it's really a more of a on the advanced side of things. And Windows does have its built-in features that it can use for like eliminating or preventing that sort of attack, mainly pertaining to like code integrity, which I believe is a Windows Defender feature, as well as like application control. So both of those are, I believe, Windows Defender features. And then, of course, practicing the principles of least privilege. So if a user were to somehow gain access to an account based on, or, they have access to an account and then they have an account that has elevated privileges, essentially, then that could potentially lead to a process injection sort of attack. In this particular case, I believe what the script did was it used Notepad in order to essentially hide the code that this executable here runs. And so the only reason why I know that is because when I ran the script, I noticed that Notepad opened up. And then there's actually a couple of tools that can be used on this VM in order to detect that sort of thing and look at the sort of malicious code. But I believe what I'll probably just do is cover that in another video. So beyond that, another thing that I would always take a look at is stuff like services. So as you can see here, a service was created for Atomic Test Service. This was injected, or I guess created by the script itself. Um, and so what you want to do, of course, is figure out what this service does, but also frankly, if you know it's malicious in nature, then there's like terminal commands that you can use to remove the service altogether in like a elevated session, I believe, through PowerShell or CMD. But yeah, that's something that I would also look at. And then if you have the proper tools, like for example, you can use Registry Explorer, which is essentially a forensics tool. I believe it's custom made by Blue Cape, the organization I mentioned before. This gives you more of a comprehensive view of the different registry hives and also gives you like timestamps, sub key values, and it's very, very useful when doing any sort of forensic analysis. And there's also a tool called Timeline Explorer, which can give you even further insights as to, what was ran at what time, um, what behaviors were detected by the system, and really, it really just gives you a, like, not necessarily a step-by-step map of what happened, but it just gives you more insight, and it aids in being able to figure out what exactly an attacker was trying to accomplish. And so that's probably something that I'll go over in another video as well. But I would say, I think that's pretty much all I wanted to cover for this video in particular. Again, this is one of the more specialized parts of cybersecurity, the Windows forensics part, where you actually go in and like look and see what exactly happened, as opposed to, just when you're a SOC analyst, your main job responsibilities would include, triaging alerts, making reports based off of the behaviors that you've seen, that through the SIM or the SOAR, and then escalating those alerts if need be. Or if you're a tier two, maybe you get a little bit deeper into the like actual analysis part of it. But again, this script here is publicly accessible, and I honestly recommend it highly because it really gives you a good like good hands-on exposure to really probably one of the most common cybersecurity attack methods out there, which is PowerShell or batch scripting. Um, and with PowerShell, since it's so powerful, it can do all sorts of things all at once in just one script. But anyways, yeah, I think that's all I really wanted to cover for this particular video. As usual, thank you all for watching, and I will see you in the next one. All right, guys, so before I end the video, there's actually one more thing I wanted to discuss. So if you're under any sort of situation where you see a suspicious file and you have no idea where the file came from, you have no idea what the file's intentions are, etc., what you could do is use the certutil command, which is essentially a command that you use in order to create hashes for a file. And then what you can do is use a platform like VirusTotal in order to analyze that hash for you, and then see if it was, one, reported by anyone else, and then two, see if it was reported specifically as malicious, or I guess benign as well. All that sort of information is important when dealing with any sort of cybersecurity activity. So to use certutil, you just do certutil hash file, and you get the path. So we will use, need to make sure I put those in quotes. And then at the end of the command, you just select the hashing algorithm you want to use. So we'll do SHA-256. And sorry, not 65. And then that should create a SHA-256 hash, unless I missed something here. All right, cool. So we got the hash. Then, of course, what we can do is copy this. And then now what you'll see is that I am on VirusTotal. What we will do now is paste that hash. Then we will search. And it looks like no comments found for your current query. Let me try one more time. All right, cool. I just wanted to make sure. But anyways, it doesn't appear that the file that I made a hash for is malicious. But if there were any reportings or any comments or anything on it, then more than likely it would be here. And that aids in, just basic file hash analysis, and just getting to the bottom of like any sort of suspicious files, or particularly whether it's executables, or maybe if it's got like a double extension, which I've seen before, like pdf.exe. Then you can, of course, make a hash for it, put it in here. And there's other websites or platforms that you can use for this as well. But that's pretty much all I wanted to cover in this particular video. As usual, thank you for watching, and I will see you in the next one.